Tags are expressions that allow us to access watch data. We can use tags for many things. We can use them to display a value or to change the appearance and behavior of a component through some logic. Let's start from 0 and display a tag's value. To do that, first I'll add a text component. On the right sidebar you can change the text component using this input here. Next to the input you can see a tags button. If you click on it, the input will expand into a pop-up, as you can see. Up here you have the input where you can type your text in tags. Below the input you have a table with the available tags and some extra information. The first column shows us the tag. These values are the ones we will need to type to access the corresponding data. The second column is a description of the tag. It explains to what data the tag will give you access. For example, the tag hour 011 represents the hour from the day. The tag hour 011Z is the same, however it has a leading 0. The third column represents the type of data that you will have access to. It can be a number or a string. String is a fancy word used in programming for text. The fourth column represents the range to which the data you will have access to can vary. For example, the tag SEC in day will return the current second of the day. A day can contain up to 86,399 seconds. So, this tag can return any number between 0 and 86399, both inclusive. The fifth column is just an example of a value that can be returned. Using the same example, 12345 is a possible value that the tag SEC in day can return. I recommend for you to check this table carefully later. There are many tags in here, and they are separated into categories. You can access date and time data. General settings like language and location. Data about the user's watch state, like battery level and sensors. Health data like heart rate and step counts. Moon phase, and weather data according to the user's location. Okay, but how do we use them? You can either type the tag or simply click on it. For example, let's test the SEC tag by clicking on it. Done, the tag was added to the input. As you can see, the tag is in between square brackets. This is necessary for the watch face to know that this is a tag. If you type it without the square brackets, the tag won't work, and WFS will treat it as regular text. Okay, the tag was added to the input. Now click on Done. As you can see, the text from the input is the tag's name. However, the text displayed in the watch face is the current second. If I press the play button, the value will change dynamically as the seconds go by. Let's try another tag. The month, that will display the full name of the current month. Now, as I change the current month, the name changes. And it also adapts the name to the user's language. You can test it out by changing the value down here, like this. You can also combine multiple tag. For example, let's say that I want to display in one text component the name of the current month, the current time in 24 hours format, a random static text, like ABC, and the current second with a leading 0. This is the expression that I need to display it. As you could see, I just clicked on each tag, and it was added to the same input. I just separated them with a space. Now let's click on Done and check the result. Watchface Studio offers us 3 kinds of operators. The first kind is arithmetic operators, which allows us to do basic math operations. The available arithmetic operators are addition, subtraction, multiplication, division, and mod. To use them inside WFS, you will need to use the symbol that represents the operator. As these are basic math operations, I won't go through each one of them. The only one I think is worth explaining is the mod operator, as it is not very common knowledge. The mod operator returns the remainder of a division. For example, if we divide 4 by 2, the result is 2. If we multiply the result, 2, by the number we divided 4 by, also 2, we will have the number 4. For minus 4 is equal to 0, therefore, 4 mod 2 is equal to 0. Another example, 5 divided by 3 is equal to 1.6 repeating. When it comes to mod operations, we only use the integer part of a number, in this case 1. The integer part of the division, in this case 1, times the number we divided 5 by, 3, is equal to 3. 5 minus 3 is equal to 2. Therefore, 5 mod 3 is equal to 2. Okay, now let's check some examples on Watchface Studio. In the text input, let's type 2 plus 1. As you can see, it simply showed the equation we typed instead of doing the operation itself. It happens because operations inside WFS need to be inside parentheses. If we add parentheses to this equation, it will now treat it as an operation and it will display the result of it. We can also do math operations using tag. For example, let's add the battery percentage tag. For that, remove this text, then click on the Tags button, then search for the battery percentage tag and click on it. This tag will give us a value between 0 and 100, but let's say we want this value to be between 0 and 1. For this we just need to divide the value from the tag by 100, like this. Don't forget the parentheses. Done. Now the value from the battery for this component will be displayed from 0 to 1, as you can see. You can even use more than one tag in the same operation. For example, let's say we want to know what percentage of the current month today represents. We can do a simple rule of 3. If the total days from the month is 100%, the current day is x. Therefore, x is equal to the current day times 100 divided by the total days of the month. Done. We just created a new math expression using arithmetic operators and 2 tags. The second type of operators WFS Studio provides are the relational operators. Relational operators compare two numbers and tell us if the comparison is true or false. True and false are represented by the numbers 0 for false and 1 for true. For example, if we write the expression 4 is less than 5, the result will be 1, because 4 is indeed less than 5. On the other hand, the expression 2 is greater than or equal to 3 will return 0, because this statement is false. Let's check it out on WFS Studio. Let's say that we want to know if the current day, today, is before the day 20. For that we add the tag day 131, the relational operator less than, and the number 20. If the current day is less than 20, the value will be 1, if it is greater than or equal to 20, it will be 0, as you can see. Let's try another example. Let's check if the current minute is equal to 0. Then let's set a time and press play. While the minute is different from 0, it will display 0, when it changes to 0, it will be display 1. Remember, 0 is false, and 1 is true. Logical operators are the third and last type of operators WFS Studio provides. Logical operators allow us to combine two relational operators, the ones we just checked. There are 3 types of logical operators, and, or, and not. And will return true when both values we added are true. In case one of them, or both, is false, it returns false. Or will return true when, at least, one of the 2 values we added is true. If both values are false, this operator will return false. Not will invert the value we added. So true becomes false, and false becomes true. Remember, false is 0, and true is 1. Let's see some examples. 0 and 1 is 0, because both need to be 1 in order for the AND operator to return 1. On the other hand, 1 or 0 is equal to 1. Because at least 1, the first value in this case, is 1. We can also invert the value. For example, if we have the value 0 and we add the NOT operator, it becomes 1. Let's check it out. Let's say we want to know if the battery level is under 15% and if the watch is currently charging. For that, let's break it into pieces. First, we check if the battery percentage level is less than 15. We already saw how to do this using the tags, like this. Then we added the AND operator, because we want to know if the battery is less than 15 and if it is charging. Then we add the tag that tells us if the watch is charging or not. This tag already returns a 0 or 1 value, as you can see here. Then we wrap our expression in parentheses and we're done. It will only display the number 1 when both conditions are satisfied, as you can see here. Let's check another example. Let's see if the current period of the day is the afternoon. For that we can use the ISAFTNON tag. It will return 0 if the current period is the first half of the day and 1 if it is the second half of the day, as you can see. If we add the NOT operator, it will invert the value. Now it will show 1 if the current period is the first half of the day and 0 if it is not. Before moving to the next topic, it is worth mentioning that WFS has a bug, at least it has at the moment I record this video. For some reason it is treating the logical operators as arithmetic operators, even though the conditions for a logic operation are met. For that reason, when we use the OR operator, it treats it as a plus operation. For example, if I try to check if it is currently afternoon or if the user watch is set to use a 24-hour format, it will add the numbers instead of doing a logical operation. When both conditions are met, it will return 2 instead of 1. If at the moment you are watching this video, this bug still exists, an easy workaround for this is to check if the result of this operation is greater than 0, like this. Conditional, also known as a ternary operation, is a way of evaluating a condition and returning a value depending on whether the condition is true or false. To simplify, you can think about conditionals as if the value is true, do something; if not, do something else. For example, if the battery level is less than 30, return the value low; if not, return the value high. Let's turn that sentence into an expression. First, we need the condition. We already know how to check if the battery level is under a number, like this. Next, we add a question mark, like a question: is the battery level under 30? Then we add the answer if the condition is true. In this case, if it is true, we want to return low, so we type low. As you can see, the word is between quotes. This happens because texts are strings, and strings must be between quotes. Then we add a colon. The colon separates the possible answers; it works as the word otherwise. Is the battery under 30? If it is, return low; otherwise. Then we add the otherwise part. In this case, the word high. So now we have built our conditional. If the battery is under 30, return low; otherwise, return high. All conditionals will have this structure: the condition, the question mark, the returning value if true, the colon, and then the returning value if false. Let's check it out on Watchface Studio. I'll type the conditional we create in here. Just remember, just like operations, conditionals must be between parentheses. Now you can see that when I change the battery level in the preview, it does not show the battery percentage; instead, it shows the words low and high. You can also have nested conditionals, in other words, conditionals inside conditionals. For example, if the battery is greater than 60, I'll return the word high. However, if the value is not greater than 60, I'll test another condition. I'll check if the battery is greater than 30, like before. If it is greater than 30, I'll return the word medium; otherwise, the word low. Functions are expressions that will take input values and will return a new value based on the inputs you've added. It's easy, you'll understand. Let's take a look on what functions Watchface Studio gives us. To do that, click on the Tags button and scroll almost to the bottom. Just like the tags, you will have the name, description, returning type, and examples in this table. Let's say we want to raise a number to a given exponent. For that we can use the POW function. You can see here that the function has a parenthesis, and inside this parenthesis we have two words separated by a comma. This means that this function takes two inputs. The names of the inputs are base and exponent. We have to replace those words with the inputs we want. For example, let's say I want to raise the number 2 to the power of 3. For that I type the function name, and I replace the names of the inputs with the corresponding values, like this. Just like everything else, functions need to be inside parentheses too. Done, there you have the result. We can also use tags in here. For example, let's say I want to raise the current day to the power of 2. For that I just need to replace the inputs with the new values, the tag and the number 2. Let's test another function. Remember that I built an expression that returns the percentage of the current month today represents? That expression returned us a number with decimal points. Let's say I don't want the decimal places from that expression. For that I can format that number using the number format function. As you can check the description, I can use a hashtag symbol to fix the places the number can have. So, I'll add just one hashtag to display only the integer part. As the hashtag symbol is a string, not a number, it needs to be between quotes. Then I'll add the next input value, that is, the number to be formatted. I'll just paste that expression I created in here. Remember that the inputs need to be separated by a comma, and the function needs to be inside parentheses. Done, we have the percentage without the decimal places. In case I want just one decimal place, I can add a dot and then one more hashtag. If I want 2 decimal places, I just need to add one more hashtag. So far, I've been teaching you some concepts on how to display the tag values. But as I said at the beginning of the video, tags can be used to customize components and add logic to the watch face. Let's see some things we can do with tags. For that I'll add a rectangle component, and I'll set the size to be 100 by 100 pixels. Now let's say we want to rotate this component based on a dynamic value. For that we can use tags. For example, let's say we want this shape to rotate 360 degrees according to the seconds in 1 minute. For that, click on the angle input. Here on the side you will find the tags button. Now let's build our expression. Each minute has 60 seconds. If we want our shape to rotate 360 degrees, we have to divide 360 degrees by 60, that gives a value of 6 degrees per second. We already have a tag that tells us the current second. We just need to multiply that tag by 6, like this. Now our shape rotates. If we want a smoother rotation, we can increase the precision. We can do that using the SEC tag. It gives us the current second with milliseconds. That looks better. I'll remove this expression for now, so we can check other settings without the shape rotating. Let's say we want our shape to increase in size as the seconds go by. For that we can add the second with the millisecond tag to the dimension inputs, like this. I'll multiply it by 2 so it can be more visible. You can also see that when the seconds turns 0, the shape is still here. It happens because we are also adding 100 to our expression. As you can see here, the initial value, the value from the input, is also being considered in the expression. If you pay attention, you can also check that the shape is increasing in size from the top left side. This is the origin point for all components. If we want it to stay in the middle, we need to mathematically fake the origin point. We can do that using tags in the placement's inputs. For example, the shape is increasing its size by 2 times the current second from the top left point. If we want it to stay centered, we just need to subtract the value it is increasing divided by 2, which equal to the current second. This expression will give us the current second with milliseconds, but we want to subtract it. If we keep it this way, it will add to the placement because of this plus sign. So, we need our value to be negative. We can do that by multiplying it by -1. Good, now it stays horizontally centered. Let's do the same for the vertical placement. We can also add the minus sign in front of the tag. It will have the same effect of multiplying it by -1. See, expanding and centered according to the current second. We can also make it rotate by adding that first expression to the rotate input field. Let's try another example. This time using conditional. We already know how to show high or low for the battery level. But what if we want to show an image instead of the text? Keep in mind that there are several ways of achieving the same result. Let's use the tools we've learned so far. Instead of returning high or low, I'll return the number 0 or 1, or any other number, like 3 and 4, you choose. In this case it is 3 when it is over 50 and 4 when it is under 50, as you can see. But it is still a text. To show an image, we can add a bitmap font. For example, let's make the character 3 a green battery icon and the character 4 a red battery icon. Cool, we've built a battery indicator using a text component, tags, operators, conditionals, and bitmap font. Now let's add a charging indicator. For that I'll use an image. I'll scale it to fit the center of the battery, then tint it black to match the background color. I'll also set the opacity input to 0 for it to not interfere in the expression. We already know there is a tag that tells us whether the watch is charging, this one. It returns 0 if it is not charging and 1 if it is. If we multiply this value by 100, it will be 0 when not charging and 100 when charging. This way we can set the opacity to 0 or 100, like this. Keep in mind that there are many ways of achieving the same result. This is one way of doing this. That is all for this video. I'll leave a link in the description for an official documentation in case you wish to read about it.